A very good morning to all my dear friends. Welcome to Unacademy. So कैसे हो दोस्तों? Okay. So confirm the audio and video part. I know it would be there. Welcome start. चलिए स्टार्ट करते हैं. फ्रेंड्स, मैं हूं आपका दोस्त ऐश्वर्य. यूज्ड टू टीच यू फॉर गेट एंड ईएससी. दोस्तों, मैंने एमटेक किया है आईआईटी दिल्ली में और बीटेक किया है जामिया मिलिया इस्लामिया से. और 4 बार मैंने क्वालिफाई किया है गेट विद माई बेस्ट AIR 226. I do have 7 years of teaching experience and 2 years of industrial experience, and all these are the subjects which I am basically taking on Unacademy official YouTube channel, Unacademy special classes, as well as on Unacademy Plus. The subjects are theory of structure, RCC, geotechnical engineering, and strength of material. Okay, so my dear friend, this is a code which you can use for buying any Unacademy Plus subscription in order to avail 10% off, which is maximum given by Unacademy. And this code is also applicable to all the other possible field. So in short, I want to say that S10 is going to be a universal code for you. Okay, so yeah. And one more thing, that soon this 10% discount is going to be reduced and it will be 5% only, and it can happen anytime, believe me. So if you are planning your subscription in upcoming days, then you can reschedule that plan and you too should take it now only. Okay. And now the question comes, why do you need Unacademy Plus? So at Unacademy Plus, you guys have access to daily live classes, crash courses are also there, weekly test is also there, doubt solving sessions are also ongoing, English and Hindi both the sessions are there, rank improvement batches is also there. Okay. And if you want to convert this plus experience into an iconic experience or into your personalized coaching, then you can go for our iconic plan. Okay, then you can go for our iconic plan. What is the iconic plan? In iconic plan, all the benefits of plus would be there, but apart from that, we are going to assign you a personal coach which is going to plan your studies, which is going to keep the study booster session for you, and which is going to analyze your test, and based on that it will provide you what are your positives and negatives. And not only this, your specialized notes and practice sets would also be covered. Is it clear? Okay, so my dear friends, then you can see the details of our upcoming batches. So e-batch is about to start. It is going to start on 22 Feb. Okay, e-batch or you can say evolve batch, 5th batch is which is targeting next year gate is going to start on 22 Feb. So you can be a part of Unacademy Plus subscription and you can get enrolled yourself into this batch. Okay, and if you are 2-year program students or if you are in 2nd year, then Ascent batch is there. And you can see you can use again the code AS10 so that you can participate in this as well. Okay, so 22 February it is going to start, and it is basically designed for 2-year students. Okay, so let's see a short video which is talking about evolve and Ascent batches. Okay. Okay, now my dear friend, not only this, if you are planning to go for ESC, then here as well you can see that we have launched a ESC batch. It is going to start today only, and in this batch we are only giving considerations, and it is our 2nd batch on the general studies. Is it clear? Okay. And if you have not downloaded the Unacademy app, then you can download it from the Play Store or from the App Store. After downloading this app, you will be able to get access to special classes, quizzes, combat, and live test series. Okay, and welcome to session number 18. And this session is about on the determination of permeability. Okay, so in yesterday's lecture, my dear friend, we have seen what is permeability, what is Darcy's law, how to calculate head loss, and how to calculate the coefficient of permeability or equivalent coefficient of permeability when flow is occurring across or along the bedding plane. When flow is occurring, you can say along and across of the bedding plane. Okay, so this we have seen already in the yesterday's lecture. Okay, today we have to find, or you can say today we have to determine how to find the coefficient of permeability, or you can say that k value. Okay, so many methods are going to be there. Laboratory methods would be there, and you can say your other than laboratory method, field method would be there, and some empirical relations would also be there. So all these things you will be able to find there. Okay, so let me start them. So this is completed, this is completed, this is completed, this is completed. So right now we are dealing with this. Okay, so now see, in order to determine the coefficient of permeability, okay, we have basically these three broader classification: laboratory test, field test, and indirect method. Okay, so maybe I will try to cover this laboratory test and indirect method today, and field test, and after that I am going to start CPS tomorrow. Okay, so let me start the thing. Laboratory test. So there are two types of laboratory test. One is constant head permeability test, and second is falling head permeability test. So what is actually happening between these tests? Here you are filling a, you can say, your soil sample with some water level, and from the name itself it is clear that here the water level we have to keep constant, and under that constant how much discharge is actually happening, how much volume is collected in how much time, that we have to measure. And by using the simple expression q is equal to kia, you will be able to calculate the value of k, because it is like this. Okay, it is like this. So this you have to find. You know what is going to be the head loss, it is going to be constant. You know the volume rate. Okay, you know the length of the soil sample, you know the area of the cross section. So if all these data are known to you, then very easily you can calculate the value of k in your laboratory. But my dear friend, I am saying this is a constant head permeability test, so keeping the head constant would be easy only in that kind of soil where head is you can say going down early, so that you can fill that deficiency and you can top up your water. Okay, so these things will be happening in coarse grain soil. These things would be happening in coarse grained soil. Now, what is there in falling head permeability test? In such kind of soil where the discharge is taking very low, very slowly, and slowly the head is going to deficient. So there you cannot top up the water like just like that, because you have to wait for so long. So in such scenario, what we will going to do? We will be using the falling head permeability test, because here we will allow our water to go down. Okay, here we will allow our water to go down, and after that with the help of some differential equation and integration, we will be able to calculate again k. But do not forget that it is basically for your fine grained soil. It is basically your fine grained soil. Is it clear? Is it clear to all my dear friends? Tell me. Okay. Okay, what is this here? Just a minute, just a minute. Okay, now all right. Okay, so let me start with the constant head permeability test. See, constant head permeability test. What is happening here? See, let's say there is a soil sample. Let's say like this. This is a soil sample, maybe in the tube and all. Okay. Good morning, Gaurav. कैसे हो? Okay, dear. You are from Ice Gate, Ahmedabad. Good. Let me draw this, and here is some soil. विशाल गुड मॉर्निंग आगे भाई. अब देखो, water would be percolating through this soil sample, and it is going to rise, let's say, till here. So this is the head loss, the total head at, you can say, see, the head loss I have to measure from here to here, because this is a soil sample, and the actual path of the flow would be from here to here, from here to here. Let's say this length would be L only. Okay, so at this point, if you are calculating, like, consider this as reference as well, consider this as a reference as well. Okay, so you, if you are seeing the level of head here, you would be finding it till here, let's say H. Okay, and datum head is 0 and pressure head is H. So overall head or total head at this point, let me call this point A, and let me call this point as B. The total head at A is equal to capital H. The total head at A is equal to capital H. Similarly, let's say the total head at B is equal to this one. Let me call it small h or h dash. Now, what head loss has occurred between A and B? At A, this was the scenario. At B, this was the scenario. Now, you can see that from here as well. Head at A would be here only. Head at B would be this one only. So, from A to B, it is going to reduce. So, this head loss, I mean to say, from here to here, this head loss is equal to this one. This head loss is equal to small h. Okay, and this head loss is happening over a distance L, over a distance L. So what is the gradient here? Gradient here is equal to head loss over the length L. And make sure one thing here, that the head at the upstream level or at a point is always constant, because it is constant head permeability test. It means you are not going to change the head. I know with the passage of time it will dip down, but you would be topping it from the top side, and such that its initial water level would be maintained, and then this head loss value will also be maintained. Okay, so because from a fixed path it is going to have a particular drop only in potential, so this head loss is also fixed. Okay, so that is the thing. Now we know that if kq is equal to k I a, then it is going to be equal to q you can measure. Okay, that how much height or is going, and you can measure the flow of water in the calibrated container. So there you can see the volume over time is equal to k I is h over l into a. Okay, so here you can find k is equal to vl upon ah t, vl upon ah t. So like that you can work here. So it is going to be equal to VL upon, you can say, AHT. Okay, is it clear? And if in some questions, if directly it is given discharge to you, then it is also equal to QL upon AH, because volume by T you can always write discharge only. So this is your coefficient of permeability. This is your coefficient of permeability. Okay, please let me know if you have any doubt. Please let me know if you have any doubt. Okay, all fine till here. चलिए, चलो next. Next we will talking about is the internet all fine? Is internet all fine? Just a minute. So next, internet all fine? Just a minute. I do not know whether I am visible or not. It is buffering on my screen. Let me check. Okay, it's fine now, I think. Yeah, buffering was occurring on my mobile device. Okay, now it is fine. Okay, so I thought some issue of connectivity. Okay, leave it. So yes, this is the expression to calculate the coefficient of permeability. I hope the things are fine till here. Now next is your falling head permeability test, or you can say variable head permeability test. Okay, falling or variable, falling or variable. Okay, falling or variable. See, I have already given you the concept that what is going to happen here. Here the water level will be going down. Okay, here the water level will be going down, and we are not supposed to top up the head at the upstream end. Or okay, so what we have to do? So what we have to do here? mm, See, let me draw a diagram. And let's say it's a container. Let me draw it with some other color. Let's say container is this. Okay. Very good morning, Sunny. Let's say the initial water level is up to here, and let it be soil inside with red color. Now this is your you can say downstream side. Let's say this is your water level. This is your water level. Okay. So I am considering for the time being this downstream water level to the reference. Let me take this as reference. Okay. So with respect to this reference, with respect to this reference, let's say the initial water level is this one. Let me call it H1. Okay. And final water level maybe, let's say up to here, from where you are performing experiment. Okay, let's say it is H2. This H2 and H1 are playing double role. They are head loss as well, and they are also available head at upstream end, because I have taken this downstream references as, you can say, datum only. Okay, and after that what will happen at any intermediate place? What is going to happen? let's say this I am removing. So at any intermediate place, if I am going to see the volume change, so this volume change would be equal to this one, and let's say the head change between this point is equal to dh. Let the head change between this point is equal to this much only. Okay, now what will happen after that? So these all are the scenarios. Okay, so here we have to establish the relation only. Here we have to establish this relation only. So how we are going to do that? So if we'll see here, then if A is going to be, let's say, area of the cross section. Okay, now what is the volume, taken in this small time, let's say dt? So that volume will be equal to area of base into dh. And yes, you can put this negative sign because volume is reducing, dh is coming down, so volume is going to be equal to minus area into dh. Okay, so that is the thing. Now this if minus a into dh is change in volume in a very small time dt, then I can also write it like this is dv only. So this dv is volume change in very small time. Okay, so let's say the arbitrary water level is this only. At particular time also, I can refer this headed equal to h. This yellow one I am representing the variable head. Okay, so volume change is very small in very small time. It is equal to v dv is equal to a times of dh, and similarly this dv into a times of dh you can also write like it is a dh is equal to q times of dt, because we know this charge is going to remain constant. So I can also write that minus a dh is equal to how much it is? This is equal to your q into dt. Please let me know how many of you are agreeing to me. So let me show to you this, that let's say initial height is h1, and after given time t, let's say this is a head at time t is equal to t1. This is a time when at t is equal to t2. At any arbitrary time t, this is the head small h, and whatever dip or volume change is occurring, so for a very short interval it is going to be equal to area into dh. So area into dh is nothing but the change in volume. Change in volume, you can also write that discharge into small time, because this change in volume I am counting in a very small time interval. Okay, so this, my dear friend, a into dh, if it is equal to q times of dt, then what is going to be the case here? So what is going to be the case here, that here you can also write your q is equal to, from the Darcy's law, k, I and a. I know you will say that, sir, I, how you can write? It is not constant, it is variable. But I am writing this expression for a smaller time interval only. Okay, so I am writing this expression for a smaller interval time only. Okay, now we have to see what we can do here. Now we can write our I. So how I can write my I? So ADH is equal to K. What is going to be I? Any idea? What is going to be the I? I is basically the change at that instant of time available head, and at that, with respect to that time, the head was H, and here it is 0 because datum is this. So this H was the head, and what is going to be the gradient at that time? So if the length of the soil sample is, if the length of the soil sample is how much? This one only. If the length of the soil sample is this one only, then at that point of time it is H by L. Okay. And yeah, one more thing. This area is the area of soil sample, and this area is the area of cross section. Okay, so let me redefine this. Let me call it small a, because this we are generally denoting with small, small a only. And this area of cross section, let me call it at capital A, from here to here. Okay, so सेम ही है, कोई टेंशन वाला बात नहीं. So this is equal to A and A. And this is equal to KI, now A. Now confusion now, that's why I have taken small a and capital A. ठीक है. Small a, let's say the area of the cross section in the flowing water, and this capital A is the soil area. So dH by H with negative sign is equal to K capital A by small a into dt. Okay, K capital A by small a, और ये L भी आ जाएगा into dt. So if I am going to integrate these equations, so at time t is equal to t1, it is equal to t2. At time t is equal to t1, let's say the water table is h1. At time t is equal to t2, now the water table has been fallen to h2. As I told you here, at t1 h1, and at final time it is t2. So in the time interval of t1 minus t2, the head has been lowered by h1 minus h2. Okay, so the similar thing I have written here. Now the only thing which I need to do here is your integration. So we know that minus dh over h, you can write it down, minus ln h, and the limits would be how much? Limits would be how much? h1 to h2. So here if you are seeing the things, so it is only dt only. So ka over al into t only, and the limits would be t1 to t2. So minus ln h2 plus ln h1 is equal to ka over al into t2 minus t1. Okay, and this k is equal to here ln h1 over h2 divided by this a into t2 minus t1 into a into l. Okay, is it clear to all my dear friends? Into a into l. So this is going to be the expression here. So al ln h1 over h2 upon at. ठीक है, al over ln h1 over h2 upon a t2 minus t1. This is it clear to all? Tell me if it is clear to all. ln h1 over h2 over a t2 minus t1 into a into l. So that is the case here. Okay, so this is the coefficient of permeability, my dear friends. This is the coefficient of permeability. And if you want to write the same in the log base 10, then your k would be how much? 2.303 log 10 h1 over h2, okay, into al over a into t2 minus t1. Generally you would like to keep t1 0, because the first reading you are going to take and you have set your stopwatch and like that. So t1 is 0 and t2 is the time interval. So generally T2 minus T1 is also written as your T only. So it is AL log H1 over H2 over A into T. Okay, so like that we will be able to write the expression. So this is the value of calculation of coefficient of permeability, and this is also the expression. Is it clear? So this is the result in falling head permeability test, and don't forget that falling head permeability test is more common in fine grain soil, because in fine grain soil topping up of the things will take really time. Okay, just a minute, my dear friend. Okay, so this is the T2 minus T1, and this is the expression for K, and this we are going to use in your falling head test. Is it clear? We will see a application on this now. Don't worry, we will see application on this. So now the next is your you can say indirect methods. So there are several equations which are going to account the coefficient of permeability indirectly. The equations are Allen-Hazen equation, Lorentz equation, Koenig-Kallmann equation, consolidation equation. So all these are some empirical formats for determining the coefficient of permeability. So let me start with the Allen-Hazen equation. So Allen-Hazen equation is simply saying that K is equal to C d10 square. Here C is the constant whose value is going to lie between 1 centimeter per second to 150 centimeter per second, and d10 you can say it is the effective size in the centimeter. D10 you can say it is an effective size in the centimeter. Okay, is it clear? Okay, so next, Lorentz equation says log 10 ks square is equal to a plus eta b, where S is the specific surface area, eta is the porosity. All these are empirical relations, my dear friend, and A and B are constant depending upon the type of soil and temperature. Okay, this is specific surface area is maybe important for you. Then how to calculate a specific surface area, that is important. Okay, so what we have to do here, just a minute. So it is equal to your surface area over volume. Suppose your particle is spherical, and you know, let's say its diameter is d only. So what is the surface area? It is 4 pi r square. What is the volume of this particle? It is 4 by 3 into pi r cube. Okay, so this and this will cancel, this and this will be cancelled, so it would be equal to 2 and 2 6 by d. So the specific surface area is going to be 6 by d for a spherical particle. Okay, a very good morning, Sushil Kumar. Okay, okay, so this is the case. After that, my next equation is your Cosny-Kallmann equation. This is also very important equation, not from numerical point of view, but this equation is really giving you the senses to the various other coefficients. Okay, like kk is your shape coefficient, as you know it is the specific surface area, e you know it is the void ratio, mu is used here is the coefficient of viscosity, gamma w is the unit weight of water. So all these terminologies you would be able to see here. Is it clear? Okay, yeah. And one more thing, that you may encounter sometime such particles which are not spherical, like they are you can say like this, rectangular and something of other shape. So what you have to do in such particles, my dear friend, you can do simply d. Suppose if it is a, it is b, then simply take the geometric mean of these two sizes. So let it be a into b. Okay, so in a specific surface area, in place of d, simply replace d with, you can say, under root of a into b. Okay, so that is the value of d here. So that is going to be your case. Is it clear? Okay, so that is the thing. Now the consolidation equation, this equation is also really important. So what is there in the consolidation equation? So K is equal to CV gamma W MV. This we can derive in the consolidation chapter, not an issue. This we can derive really. And here CV is the coefficient of consolidation, MV is the coefficient of volume compressibility, and gamma W is the unit weight of water. That is the scenario here. Okay, so coefficient of consolidation, volume compressibility, and gamma W is the unit weight of the water. So this equation is also going to help you in your consolidation. Important for numericals. Important for numericals. Okay, you should keep always this equation in your mind. Is it clear? So all these are the ways by which we can find our coefficient of permeability. Okay, isn't it? Now the field test is also there, but I would like to speak on this tomorrow in detail. And you know, this on this formula, you can see the question was there in this GATE exam. Okay, so I have also covered that question on YouTube as well as on special class, but tomorrow I will be going to take these formulas and derivation in detail. So what, how to get the formulas for coefficient of you can say consolidation or permeability, sorry, not consolidation, in confined aquifer and confined aquifer. And before that, I would like to introduce you what is aquifer, aquiclude, acutard, etc. What is the pumping test, how we are going to do the pumping test and all. So basically I am going to cover tomorrow well hydraulics. Okay, so well hydraulics, or you can say your field test. So both topic I am going to merge, and I would like to take a special session on that. So that would be live morning at 8:30. Okay, so we can solve some problems on this. And yes, all these are the factors which depends upon the coefficient of permeability, like particle size, shape, void ratio, structure of the soil, unit weight of the soil, viscosity of the soil, impurities present in the water, as well as your adsorbed water. Okay. Yes, Shabi. Yes. Yeah, हाँ वो mention करना भूल गया. Coefficient and coefficient of permeability. Also one question is there, है ना? So this anyway I am going to derive in consolidation, but it's let me tell you one thing, its derivation is not really required, because the derivation is going to take care of many coefficients. We are giving them another name like that, then we are deriving. So but this is, that's why I said that is really important. And from this well hydraulics, this time the question was there, and I'm going to cover all the cases because it will be a time taking. I would like to take one or two numerical what we have studied today. Okay, so all these are the factors which are affecting the permeability. Now there are some type of soil whose permeability has been given. Gravel is 1 centimeter per second greater than, sand is going to lie between 1 centimeter per second to 0.001 centimeter per second. Silt is going to lying between 10 to the power minus 3 to 10 to the power minus 6 centimeter per second. And similarly clay is also. So clay is considered to be impervious, and gravel is very pervious, sand is also pervious, and silt, you can say, it is only slightly pervious. Pervious means which can allow the passage of water through it, or which is having a good coefficient of consolidation. Okay, so let me have some questions. So let's do it. If during a permeability test on a soil sample with a falling head permeability test, if equal time intervals are noted from drop off head from H1 to H2 and again from H2 to H3, then which of the following relation will hold good? Then which of the following relation will hold good? Okay, so tell me. Hmm. So write down your answer. See, Shabin, uh, the difference between pervious and porous is that porous is something which can retain water in it. Okay, like clay. Clay is also porous because clay is also having a large void ratio. So if void ratio would be large, then automatically your porosity would be increased. Okay, so porosity is somewhat related to your, you can say, void ratio. Okay, but pervasivity is about interconnectivity of the voids, is about coefficient of you can say permeability. If more permeability would be there, then you are going to call the soil as permeable soil, or you can say your pervious soil, pervious, or you can say permeable. But porosity means, porous means void ratio. Even clay is more porous, but clay is not pervious, isn't it? Clay is known as your impervious. Is it clear, Shabin? Okay. So what you are going to write here, what you are going to write here, if during a permeability test on a soil sample with falling head, if equal time intervals are noted for drop of head from H1 to H2 and again from H2 to H3, then which of the following relation will hold good? Okay. Sometimes back we have derived the relation in case of your falling head. I hope you all remember that. Okay. So what we are going to do now? What was the final expression for coefficient of consolidation? It was I1 K is equal to AL, or you can say 2.303 AL log at base 10 your H1 to H2. Okay, and this is going to happen over a time interval of T, or you can say T2 minus T1. So divided by A, T2 minus T1. Okay, but time interval they are saying is equal. So in the first time interval, so if time interval is equal, okay Shamala, let's see. If time interval is equal, so this is your T2 minus T1. So let me call it T only. So if this is your T only, then T would be equal to 2.303 L log, just a minute, AL log 10, and from first it was H1 to H2, and it is equal to A times of K. See, all other parameters are same. So next time it is going to be H2 to H3. So this time we have to write it like 20303 AL log 10 H2 to H3, because time interval is same. So this is going to be cancelled. This and this are also going to be cancelled. So you can simply write that your log 10 H2 over H3 is equal to your log 10 your H1 over H2. So H2 square is equal to H1 into H3. So H2 is going to be equal to, yeah, this is only. Very good, Shamala. Very good. Great. Okay. So correct answer is B only. Good one. Next, tell me. Consider the following statement. Constant head permeability is best for determination of coefficient of consolidation of highly impervious. Highly impervious means clay and silt or your fine grained soil. Coefficient of permeability of soil mass decreases with increase in viscosity, and coefficient of permeability of a soil mass increases with increase in temperature. So tell me what all are the statements are correct. Okay, tell me what all are the statements which are correct. So any idea? Okay, I told you constant head permeability test. See, especially I have written here, if you remember, that this constant head permeability test, it is basically designed for coarse grain soil. Coarse grain soil means that soil which is going to have bigger particles, or which is going to have good void ratio, good interconnected voids. Okay, then only the head is reducing and here you are topping up the water. So coarse grain soil, and we have seen these are soil, sand and gravels, and they are already pervious. But right now the statement number 1 is saying that it is going to be highly impervious. So how can statement number 1 can be correct? So whatever is saying 1, 1, 1, simply I have to eliminate that and I will be able to get my answer, because I know the statement number 1 cannot be correct, it is written opposite. And we can also justify it. Yes, good Shamala, we can also justify other statement. Statement number 2 is coefficient of permeability of a soil decreases with increase in viscosity. Yes, they are inversely proportional, like we have seen this Cauchy-Corman equation. So here you can see that this coefficient of your consolidation is inversely proportional to the coefficient of viscosity. Okay, and what was the third point? Third point is that your coefficient of permeability of a soil mass increases with increasing temperature. In liquid, what will happen if the temperature is increasing, then their viscosity is reducing. If viscosity is reducing, then ultimately its coefficient of permeability is increasing, because coefficient of permeability and viscosity are inversely related to each other. Is it clear to all my dear friends? Okay. Okay. So, so this is the, you can say, question. Attempt it and tell me the right answer. Which is going to be the right answer? The following data were obtained when a sample of medium sand was tested in a constant head permeameter. Means it is case number 1 for coarse grain soil. The area of cross section of the sample is 100 centimeter square. Hydraulic gradient is 10. Discharge is 10 cc per centimeter cube per second. So you have to find the coefficient of sand, coefficient of permeability of sand. Okay. So it's not a very high time when we have derived this. Just now only we have seen. So I think this is the expression, that K is equal to VL upon AST or QL upon AH. Okay. If it is equal to QL upon AH, in that case, what you can write here, K is equal to QL over AH. So what is Q? 10 centimeter cube per second. What is the length? Length is not given. What is the area? Area is 100 centimeter square. What is H? H is given. No, H is also not given. But what is I? I is H by L. So you can write it like 10 centimeter cube per second. Okay. You can write it like K is equal to 10 centimeter cube per second. Okay. Divided by 100 centimeter square. Divided by 100 centimeter square into L by H. So I'm going to write L by H as 1 over H by L. So it is your 10 centimeter cube per second divided by 1000 centimeter square. It is 10 to the power minus 2 centimeter per second. Okay, 10 to the power minus 2 centimeter per second. So all the options are in meter per second. So in meter per second it is 10 to the power minus 4 meter per second. This is the coefficient of permeability. So I would like to go with option yes, Shamala, very good, C. So correct option would be C. Okay, is it clear? Great. Now the last question of the session, it is from yesterday's session, you can do it. So what are you saying? Let me check. Sir, where can I get lectures on geotechnical engineering from starting? I want to understand from the introduction. Neetu, this same channel, na? This same channel, Unacademy GATE CECH, and today is the I think 18th lecture. So earlier 17th lecture you would also be able to find. Okay. So not an issue for that. Okay. Okay. Is it clear? Yeah. So there are stratified soil case. Okay. So let's say this thickness is 4 unit. This is 4. This is 1. This is 2. Okay, thickness although I have shown you equally, but these are thicknesses are different. If I'm talking about coefficient of permeability, it is 2, it is 1, it is 4. Now the average permeability perpendicular to the bedding plane means it is going to be like this. So it is your series connection. So in series connection, how you are going to find the permeability? It is H1 plus H2 plus H3, okay, divided by H1 over K1 plus H2 over K2 plus H3 over K3. So 7, you can say 2 and 3, 3.5. So answer is 2. Okay. So it is coming out to be. See, it is average across perpendicular. So perpendicular is like this. Yes. B. Great. So Shamala is right in all the questions. So thanks a lot, my dear friend. Okay. And tomorrow I am going to cover the well hydraulics. Well hydraulics. Okay. So 8:30 a.m. onward. And this is the channel where we are working, and I have already given you these subjects RCC and structural analysis, and geotechnical new part has been given to you, and now I am working on the core geotechnical portions. And my dear friend, this is information for you who are preparing for GATE 2022 that on 22nd of February we are going to launch our 5th batch, and you can be a part of this by using the code ASH10. And on 22 Feb again we are launching a batch, ascent batch for GATE 2023 aspirant. Here as well you can use the code ASH10 if you want to be a part of this batches. Okay, so we may be having this small video in this description. Okay, so see, and for engineering services we are targeting our batch B, which is going to start today only, because general studies is going to be a key role in your batches, in your preparation. So ASH10 is going to be key there. Okay, and all these are the prices for our plans. that for plus, my dear friend, for 1 year you have to pay 27,225. For 1.5 year you have to pay 34,650, and for 2 year it is 39,600. Okay, for 2 year subscription. And for Iconic, my dear friend, for 1 year subscription you have to pay 45,225, and 2 year you have to pay 66,600. Okay, so Iconic is slightly on the higher side, and it is due to the obvious reason. As I told you here, the personal coach is also going to involve with you guys. Okay, so guys, always free to follow me at Unacademy at the rate Sharma Aishwary -1049, and this is our official Telegram channel. So, and this is our channel in which we are associated, and right now you are watching me live in this channel, which is also known as the one-stop solution for all your engineering problem. Okay, so thank you guys, thanks a lot, have a nice day, stay safe, and don't go outside if it is not required.